Hello. Welcome back. We're going to do 8-2 today. And this is really exciting. We're going to start our first look at what we call trigonometric function or ratios, um, or just trig ratios. You'll hear me say more because it's way faster, right? Um, so, you know, our little, we usually just say trig ratios to shorten it down. So we have two objectives for today. We're going to define and learn how to calculate sine, cosine, and tangent ratios. Remember, ratio is just a fraction, right? And then we're going to use trig ratios to solve problems. So we're going to look at how do we use those ratios. A lot of new vocabulary today, which is exciting. So we actually have 6 new vocabulary. So we're going to scroll down to the end of our packet and look at our new vocabulary first. All right, so here we are on our terms page. The first term that we're going to go over today is proportion, which is like what we talked about all in Unit 7, right? I don't know why we're just now defining it. Okay, but proportion is just an equation that states that two ratios are equal. So like if I have a ratio, A over B is a ratio, it's a fraction, equals C over D. Okay, that would be a proportion. And then I could solve it by cross multiplication. So again, in topic 7, that's like all we did was proportions, right? But our new stuff today, I guess we have ratio 2. Ratio there is just a comparison of two numbers using division. So it's just a fraction, right? Like 2 to 5 is a ratio or whatever. So when we're talking about these new terms, and I want to keep scrolling here, we're going to actually go down and talk about trigonometric ratios first, and then we'll go back and talk about sine, cosine, and tangent. So trig ratios. These are ratios that relate the sides of a right triangle to the angles of a right triangle. So specifically, they're ratios of two sides of a right triangle and an angle. So if I draw a right triangle here, actually, instead of drawing it, let's just write it out. So trig ratios, there's 6 of them, but there's actually only 3 that we're going to look at in this class. And they are these 3 right here, right? Sine, cosine, and tangent. Sine, cosine, tangent. So in sine, I guess we'll use that. Let's say I have a right triangle. So let's go ahead and draw a right triangle. Boom, there it is. And I'm going to label this right triangle A, B, and C. Okay. So sine specifically, if I'm talking about a certain angle, so let's look at this and let's call this angle. What we typically use when we're talking about angles is we'll just use the letter of the angle, but if for an unknown, we're going to use theta. It's like a 0 with a line through it, like a horizontal line through it. Okay, so sine of this angle is the ratio of the opposite leg to the hypotenuse. So what you're saying is what side is opposite of this angle, right? Like on the opposite side of this angle. So opposite would be over here. We can just call this, let's just call this X, Y, and H. Okay, so X and Y are legs. H is the hypotenuse. So my opposite side of B is X, okay? So it's a ratio. So what we say is sine of B, my dog's gonna play with his squeaky toy now, is equal to the opposite side over the hypotenuse. Okay, so I would need to find what is the opposite side of B. So opposite of B is X. And then the hypotenuse of this triangle is H. So whatever the value of x is, right? Let's say it's 7 or whatever, right? That number goes here, and then whatever the value of h is goes on the bottom. And it's just a ratio because it's a fraction. Okay? Let's say I have this same triangle. So I'm going to draw the exact same triangle, A, B, C. Here's my right angle. I'm going to call my legs X and Y, and I'm going to call my hypotenuse H again. Okay? Cosine, remember this is just the name of it, okay? So cosine is the ratio of if I have this unknown angle, right? Again, cosine of B. Notice we abbreviate. Here on sine, we took off the E. Here on cosine, we took off the I and E. So cosine of B is equal to the adjacent side over the hypotenuse. Okay, so I only have 3 sides, right? From B, I have X is opposite. It's across from it. H is the hypotenuse. The adjacent side is the leg that touches the angle that you're looking for. So here, cosine of B, X is not adjacent because it's opposite, right? It's across from B. So my adjacent side is Y. And then it's over the hypotenuse, which in this case is H. So if I knew what Y was and I knew what H was, right, I could plug that in. So again, they're just, it's just a ratio. It's just a fraction. The last one is tangent. So again, I'm going to draw my right triangle here. A, B, and C. Here's my right angle. This is X, Y, and H. And let's just stick with angle B. I can do all of these for angle A as well, right? So tangent, so we abbreviate it with TAN, of angle B, so that's what that means. Tangent of angle B is equal to opposite over adjacent. So that is the ratio here. So if I want to find tangent of angle B here, the opposite side is X, so X will be on top. And the adjacent side is Y, so Y will be on bottom. And those are just my 3 trig functions. And again, they're just setting up fractions. And we'll have a lot of practice with this. But I think the most important thing right now is just knowing if I'm talking about angle B, X is opposite because it's across from it, right? Y is adjacent because it's touching that angle. And then H is always the hypotenuse. So when we look at our 3 ratios here on trig ratios, what's helpful is that we use what we call SOHCAHTOA, and it's just a helpful way to remind us what to use. So what it means is, if I write it out, I usually do a big S, and then OH next to it, and then a big C, AH, and then a big T, OA. So this is, if you say it phonetically, right, it's so, right, S-O-H, so, ka, toa. And it helps you remember that sine is equal to O over H, opposite over hypotenuse, right? And then it helps you remember that cosine is equal to A over H, so adjacent over hypotenuse. And then TOA reminds us that tangent is equal to O over A, so opposite over adjacent. So that's how SOHCAHTOA can be helpful to us by reminding us what the ratio is. Is it opposite over hypotenuse, or opposite over adjacent, or adjacent over hypotenuse, right? So that just helps us find that. Okay, that is it for our vocab. This right here is going to be the most important thing that we're doing today is SOHCAHTOA. So we're going to go back to the start of 8.2 and we're going to write this down at the top of that page so that we don't forget what our trig ratios are. So let's go back to 8.2 and get to practicing this stuff. Okay, so here we are at 8.2. And we're going to just write down our SOHCAHTOA. Somewhere on here where it's easy to find and we can see it and read it and it's nice and big and it reminds us what our trig ratios are. So example 1 says, what are the sine, cosine, and tangent ratios for angle H? So specifically from this angle right here, right? So I'm going to start with sine just because it's first. So sine of H equals, now if I look, sine is opposite over hypotenuse. So I need to figure out what's the opposite side to H. Well, the opposite side is always the one across from H. So opposite is 12. And then my hypotenuse is always across from the right angle. So it'll be 12 over 15. And that's it. That's my ratio. Okay. Now, remember, if I was doing from angle F, my opposite side would be 9. And my hypotenuse would be 15. So the ratios change depending on what angle you're looking at. Okay, now let's look at cosine. So cosine, and actually typically I put the H in parentheses, so I don't know why I haven't been doing that. So cosine of H, so here again, here's H, is A over H. So the adjacent side over the hypotenuse. Well, my adjacent side is always the one right next to my angle. So that's 9. And my hypotenuse is always across from the right angle. So that's 15. And there's my ratio. Again, that would change if I was looking at angle F. And then the last one is tangent of H, which looking here is opposite over adjacent. So here's H. My opposite side is 12, and my adjacent side is 9. And those are my 3 trig ratios. And that's it. Okay, I want you guys to try this. This next question says, what are the sine, cosine, and tangent ratios for angle F? So now we're looking at angle F, and I want you to write sine, cosine, and tangent ratio. Go ahead, pause the video, use the example up above to help you. Pause the video, and then when you're ready to go over it, hit play. Okay, so hopefully you tried this. Even if you messed up, that's okay. So we're going to start with sine of angle F, right? So in this case, I'm going off angle F, so I'm not going to have the H, I'm going to have the F. So sine is opposite over hypotenuse. So F, opposite of F, is 9. Over hypotenuse still doesn't change. It's still the same triangle. Hypotenuse is always across from the right angle. So that's 15. Okay, cosine of angle F. Let's look. Let's get rid of this. Cosine, if I look at my SOHCAHTOA, is adjacent over hypotenuse. So my adjacent side to F is 12 over my hypotenuse is still 15. And then the last one is tangent of F. And looking at SOHCAHTOA, tangent is opposite over adjacent. So my opposite side is 9, and my adjacent side is 12. So these ratios change, right? Because tangent of H was 12 over 9, but tangent of F is 9 over 12. So it changes depending on what angle you're looking at. So it just depends on that. You guys have one more try it here. I'm going to clear this. I'm going to scroll down. One more try it. Notice here you don't have an image, right, or a diagram. You will have to draw one. Okay, if it helps, we can write our SOHCAHTOA here. But you will have to draw your triangle and label it accordingly, and then that will help you to kind of look at this. So go ahead and draw your diagram, label it, and then see if you can figure out what are the sine, cosine, and tangent for angle B. Okay, so I'm going to start with drawing a diagram. Okay, and I'm just going to label it A, B, and remember C, or the hypotenuse is always the longest side. So here, 26 is the longest side, so that has to be across from C. The other two don't really matter as much, so I'm going to call this one 1 and then call this one 24. Okay, so I'm looking specifically at angle B here. So I'm going to start with sine. So sine of B is equal to opposite over hypotenuse. So opposite of B is 1 over hypotenuse is 26. Oops, I didn't draw my right angle. There we go. Right? So the hypotenuse is 26. Then cosine of B is equal to adjacent. Well, here on B, 24 will be my adjacent side over hypotenuse, which is 26. So I'm just setting up fractions. And the last one is tangent of B, which is equal to opposite, which is 1, over adjacent, which is 24. And there are my three holy moly, you guys. Hold on. I am so sorry. Side B is 24. Side A is 1. That changes it. I'm sorry. So opposite, sine is opposite over hypotenuse, so that is 24 over 26. It just switched them. Cosine of B is 1 over 26, and then tangent is 24 over 1. I'm sorry, it just flipped the fractions. Right, because A was 1, B, side B was 24, and then side C was 26. I am so sorry. Huh. That's what we get for working late, huh? Okay, let's look at example 2. And I want some more room here. Again, if this helps you to write your SOHCAHTOA as we go, please do. And this is on the word wall in the classroom as well. So example 2 says, what are the sine, cosine, and tangent ratios for 30, 45, and 60 degrees? Okay, so what we're going to do is I'm going to draw a right triangle. And I'm going to call this a 45, 45, 90 triangle. And so we have to think about the ratio, right? In a 45, 45, 90 triangle, if this leg is 1, this leg, is also 1, and that means the hypotenuse is square root of 2. So again, that's just that general pattern from a 45, 45, 90 triangle. So let's then go ahead and find the sine, cosine, and tangent ratios for 45 degrees. And let's just use this one. Okay, let's look at this one. Okay, so sine is opposite, which is 1, over hypotenuse, which is the square root of 2. And I know we talked about it last lesson, but just a quick reminder, I cannot have the square root of 2 on the bottom of a fraction. So I have to multiply it by square root of 2 over square root of 2. And what that does is 1 times square root of 2 is square root of 2 on top. And then square root of 2. My dog is really funny. And then square root of 2 times square root of 2, the square roots just go away and I get 2. So sine of 45 degrees is square root of 2 over 2. Okay, if I'm looking at, let's look at cosine now. Cosine of 45 degrees. Cosine will be adjacent over hypotenuse, which is the same thing as opposite over hypotenuse in this case. So cosine of 45 is also square root of 2 over 2. And then tangent of 45 is equal to opposite, which is 1, over adjacent, which is also 1, and 1 over 1 is just 1. So there's my sine, cosine, and tangent for 45 degrees. I'm trying to get that same purple color back that we had before. Okay. Now, let's look at our 30, 60, 90. I actually probably want to draw it a little bit bigger than that so we can manipulate it. Let's look at our 30, 60, 90. Okay, so I'm going to call this one the 30 and this one the 60. Okay, so as a reminder, if this length is 1, that means the hypotenuse is 2 times that, which is 2. And that means that the length with the 30 is 1 times square root of 3, which is just square root of 3. So let's look at our 60 degrees first. Let's do sine of 60. 60, so sine is opposite. So the side opposite is square root of 3 over hypotenuse, where my hypotenuse is 2. Now remember, I'm allowed to have a square root on the top, just not the bottom. So this is fine. Cosine of 60, right, is adjacent, which is 1. So 1 over hypotenuse, which is 2. And then tangent of 60 is opposite, which is square root of 3, over 1, which is just square root of 3. So I can say square root of 3 over 1, but that's just square root of 3. So tangent of 60 is just square root of 3. So that's if I do it from 60. Now let's look at 30. So sine of 30. So now I'm looking here at this angle, 30. So sine is opposite. Well, opposite of 30 is 1 over hypotenuse. My hypotenuse is 2. Cosine of 30, my adjacent side is square root of 3 over hypotenuse is 2. Right? I'm just following SOHCAHTOA. And then tangent of 30 is equal to opposite, which is 1, over adjacent, which is square root of 3. And then I can't have a square root on the bottom. So I have to multiply this by square root of 3 over square root of 3. Which gets me 1 times square root of 3 is square root of 3. And then over square root of 3 times square root of 3, the square roots go away, and I get just 3. It's an ugly 3, though. It can be better. Okay, so tangent of 30 is square root of 3 over 3. So here it says, how are the sine and cosines of complementary angles related? Okay, so complementary, first of all, let's make a little note here that complementary, just as a reminder, equals angles that add to 90 degrees. Okay, so that's complementary. So I'm talking about here like 60 and 30. Okay, So if we look, sine of 60, sine of 60 is root 3 over 2. That's equal to cosine of 30. They're the same thing. And 60 plus 30, right, equals 90. So they are 60 and 30 are complementary. And that will always be the case, right? Like cosine, I'm just going to start making up numbers. Cosine of 70 is going to be equal to sine of 20 because 70 and 20 are complementary. And so it's going to be opposite there. Sine of 40 equals cosine of 50 or whatever, right? So I'm just making them all up. Sine, let's do cosine first, even though it doesn't matter. Cosine of 89 is going to be equal to sine of 1. So how are sine and cosine of complementary angles related? They are the same. Okay. So they are the same, meaning sine of 1 angle is equal, hopefully you guys are writing smaller than I am, to cosine of the other. Right, so sine of one angle is equal to cosine of the other angle, as long as the two angles are complementary, meaning as long as the two angles add to 180, add to 90, not 180, add to 90, the sine of one is equal to the cosine of the other. So we have a try it here. Okay. So here it says in this triangle, it's a right triangle, it's a 30, 60, 90. What is the value of y? Okay, so it's a 30, 60, 90, so it might be helpful to write down the pattern of our 30, 60, 90, right? If this is x, this is 2x, and this is x square root of 3. Okay. So if I do this, I know that 9 is equal to x squared of 3. So 9 is equal to x square root of 3. And then I can find my x value. So I'm going to divide by square root of 3, divide by square root of 3. So I get x is equal to 9 over the square root of 3. I cannot have square root of 3 on the bottom of a fraction. So I have to multiply both the top and the bottom by square root of 3, which is fine. And on the top, I'm just going to get 9 root 3. And on the bottom, I get 3. Can I simplify this? Heck yeah, right? 9 over 3, 9 divided by 3 is 3. So this can simplify into 3 root 3. So that tells me that this length right here is 3 square root of 3. Okay, and that means that whatever that is times 2 gives me y. So y is going to be equal to 3 square root of 3 times 2. Well, when I multiply this times 2, the 2 can only multiply by the 3 outside the square root, so it just becomes 6 root 3. So y is equal to 6 root 3. And that's it. That's as far as I can go. Okay. So for B, even though it's a try it, we're just going to do it. Unless you want to pause it and try it, which, of course, at any point you can always pause and try something. B says, how can you write an equivalent expression for cosine of 70 using sine? So I need to know what is the complement of cosine 70, or of 70 degrees. So cosine of 70 is going to be equal to sine of the complement of this. Well, what plus 70 gets me 90, right? And it's 20. So there's my answer, sine of 20. I want you to try this one real quick. Write the equivalent expression for sine of 34 degrees. And I want you to write it in terms of cosine. So take 5 seconds or so and do that. Okay, so our job here was to find the complement, right? What plus 34 equals 90? And we should have gotten 56. So 34 plus 56 equals 90. So sine of 34 equals cosine of 56. So just knowing that we can go back and forth there too. Okay, we're going to start getting into using these trig functions to solve problems. Trig ratios, not functions, sorry. I'm going to end up saying that a lot because we're doing trig functions in my other class. Okay, so example 3 says use trig ratios to find distances. So here we have a drawing. If you did not have a drawing, you should make a drawing. Like pretty much all the time, that's the answer. If you don't have a drawing, make one. Okay, this says a plane takes off and climbs at a 12-degree angle. So I know that this is 12. Is that angle sufficient enough to fly over an 11,088-foot mountain that is 12.5 miles from the runway? Or does the plane need to increase its angle of ascent? So if that plane goes, is it going to run into the mountain or not, basically? So I need to look at what information I'm given. I have a right triangle. If I go across, right, this is what I'm trying to find. What's the height of the plane at this point? Is it going to hit the mountain? X to the 12 is opposite because it's across. So I know that this is opposite. And then the 12.5 to the 12 is adjacent. It's not the hypotenuse because the hypotenuse is always across from the right angle, right? So I'm given opposite and adjacent. And so I then want to solve. So I need to figure out if I have SOHCAHTOA, which one uses opposite and adjacent? So here it's opposite hypotenuse, adjacent hypotenuse. So tangent is using opposite and adjacent. So it's tangent of my angle. Well, my angle is 12 degrees, right? Is equal to opposite. Well, my opposite side here is x over adjacent. My adjacent side is 12.5. And this is just something that I'm going to want to solve for. I want to get the x by itself. Okay, so right now the x is being divided by 12.5, so I'm going to multiply both sides by 12.5. That ends up canceling these guys out. And it leaves me with 12.5 times tangent of 12 degrees equals x. And then this is something that I can put into my graphing calculator, or even if you have a blue scientific calculator, you can do this. And I'm going to show you how to do that right now. Okay, so if I want to enter this into my calculator, pull up my calculator, the first thing that I have to check, which is really annoying and really easy to forget, is whether or not I'm in radians or degrees. Because I'm given this angle in 12 degrees, I have to be in degrees. So I'm going to go into mode, and I'm going to go down, down, down. And where it says radians, I'm going to go to the right, and I'm going to hit enter, and I'm going to change it to degrees. So now at the top it says degrees. And that's really important, okay, because the angle is given to us in degrees. So if I want to enter this into my calculator, I just do 12.5. There it is. So 12.5 times tangent. So here's sine, cosine, tangent right here. Okay, so I just hit tangent and of the angle, which is 12 degrees. And I don't have to enter the little degree symbol because I have already told my calculator that I'm in degrees. And I hit enter. So I get about 2.6, let's just say 2.66. Okay, so I get x is about 2.66. And remember, this is miles. 12.5 was in miles, so I'm in miles. So the plane will be about 12.66 miles, plural, high. And I want to know, is that going to clear an 11,088 foot mountain? So I'm in two different units. I'm in feet and I'm in miles, and I don't want that. So let's figure out how many feet 2.66 miles is. So 2.66 miles. If I want to convert this to feet, I draw a blank fraction. Miles is what I'm trying to get rid of, so that needs to go on the bottom. And then feet is what I want to get to, so that goes on the top. And then I need to write this conversion. So I know that 5,280 feet is in 1 mile. And now I just have a fraction I just multiply straight across. Miles cancel. So 2.66 times 5,280, I guess I should say, is about 14,028 point, I don't know, let's just say 14,028 feet, more or less. Okay, so that's how tall the plane will be at 12 miles away, right? So the mountain is 11,088 feet. The plane will be at 14,028 feet. So the plane will be high enough to clear the mountain. So we can say, so, my pen's starting to jump. Plane will be higher than the mountain, right? 14,000 is bigger, taller than not that mountain, than the mountain. 14,000 feet is taller than 11,000 feet, so the plane will clear the mountain by about 3,000 feet. So hopefully that makes sense. That's like an example of how we would use our trig ratios. We have a try it here using the exact same idea. But again, I don't have an image already. I don't have a diagram. So we're going to have to draw one. Okay, so if it helps you, you can write your SOHCAHTOA. And it says, if a plane climbs at 5 degrees and flies 20 miles through the air as it climbs, what is the altitude? That's the height, right, of the plane to the nearest foot. So I'm going to draw my triangle. Here's the plane. Yep, there's my beautiful plane. Okay, and it's taking off at 5 degrees. And it's going 20 feet through the air, miles, so 20 miles, wow. And I want to know what is the altitude to the nearest foot. So there we go. So you're going to have to figure out what information do I have, so which trig function am I going to use, and then we're going to, solve using that trig function just like we did on the previous problem. So I do really want you to try it. If you mess up, it's no big deal. But if you don't try things using, your own brain power, it's not gonna, you're not gonna understand the material as well. So go ahead, pause the video and try it, and then when you're ready to go over it, hit play. Okay, so let's look here. Hopefully we tried it. So we need to figure out what sides we have. So x, here's my 90-degree angle, excuse me. So x is across from the 5 degrees, right? Everything goes off the angle we know. The angle we know is 5 degrees. X is across from that, so that's opposite. And then the 20 is across from the right angle, so that's my hypotenuse. So which trig function uses opposite and hypotenuse? And hopefully we said, oh, here it is, sine, right? Opposite over hypotenuse. So this tells me that I have sine of my angle, well, my angle is 5 degrees, equals opposite, which is x, over hypotenuse, which is 20. Okay, and I want to get rid of that 20, so I'm going to multiply by 20 on both sides. These cancel, and I get 20 times sine of 5 degrees equals x. So now I'm at a point where I can go and enter this into my calculator. Okay, so let's clear this. 20 times, now I'm using sine, right? Sine of 5 degrees. And I don't have to do the degree symbol because I'm in degree. And if you're using a blue scientific calculator, sines and cosine tangent are buttons on there too. So I get 1.743, let's say. So x is about 1.743 miles, right? But I don't want miles, I want feet. So I need to do the same thing I did before. So 1.743 miles. I want to get rid of miles, so it's on the bottom. And I'm going to convert it to feet. And the conversion is 1 mile is 5,280 feet. So I can do this in my calculator. So let's go back to our calculator. I'm going to take this number and multiply it by 5,280. And I get 9,203.65. So the plane's, let's say, altitude is about, right? This is a word problem, so I have to answer in a sentence. 9,203.65 feet. And there it is. So the plane's altitude is about 9,203.65 feet. So again, just using that trig function. Okay, we have another try it here. Okay, so I have a right triangle. It says a carpenter installs a brace to hold up a sagging gate so that it's square. This is a right triangle. I want to know how long is the brace. It's right there. Okay. So here's the angle I know. So I have to ask myself, what sides do I know using SOHCAHTOA? So I want you to go ahead and pause the video here. Try it, see if you can figure it out, and then when you're ready to go over it, hit play and we'll look at it. Okay, so here's my right triangle. The angle I know my opposite side, right? So 3 feet is opposite. And then my hypotenuse is the unknown because that's what's across from the right angle. So again, which trig function uses opposite and hypotenuse, and that will be sine. So I can say sine of my angle, which is 33.847, is equal to opposite, which is 3, over hypotenuse, which is x. Now, the only way to move things around here is I need to multiply both sides by x. I cannot multiply both sides by 3. 3's on the top. So I can only multiply by what's on the bottom. So those guys cancel. And I get x times sine of 33.847 equals 3. But I want this x by itself. So now I'm just going to divide both sides by sine of 33.847 divided by, right, 33.847. So x is equal to, there's a 3 on top, and then on the bottom is sine of 33.847. And again, that's something that I can enter into my graphing calculator. And it doesn't have to be graphing. I know I keep saying that. It doesn't have to be a graphing calculator. You can enter this into any calculator, okay? So either one of those Blue Scientifics or graphing or whatever. So how I do that is just 3 divided by, again, we're using sine. And then the angle is 33.847, right? The angle is always what goes inside the trig function. And I hit enter. There it is, 5.39. So x is about 5.39, and then the unit is feet. And then the question really is, how long is the brace? So we have to answer that question. So the brace is about 5.39 feet. And there's my answer. Okay. Cool. So we have one example left, and it's kind of working backwards here. And I'm going to show you how to use what we call trig inverses to find the angle measures. So what if it's the angle that you don't know, right? How do you solve for that? So example 4 says, what is the measure of angle A? So let's just look at that first. Angle A. Well, from angle A, I know that the 1 is adjacent and that the 4 is hypotenuse. So if I have my SOHCAHTOA, adjacent and hypotenuse is this one right here, right? Cosine. So I'm going to say, hey, I know that cosine of my angle, which is angle A, is equal to adjacent, which is 1, over hypotenuse, which is 4. Now, our first instinct here is like, oh, we'll just divide by cosine. Well, you can't do that because cosine by itself means nothing. Okay, you have to have some sort of angle with it in order for it to mean something. So you can't just divide by cosine. But what you can do is take the inverse of their cosine. So it's cosine with a little -1 up top, and it looks like a, I don't know why I just wrote an S. It looks like a little exponent, like a little -1 exponent, but it's not an exponent. So we can take what we call the cosine inverse of both sides, and that ends up canceling out the cosines. So that leaves me with A is equal to the cosine inverse of 1 over 4. Okay, and I'm going to show you how to do that in your graphing calculator, or scientific. Either way, above sine, do you see above sine there's sine -1, above cosine sine -1, and above tangent -1? Those are your inverse functions. So to get to those, you hit second, and then I want the cosine inverse. And I want the cosine inverse of 1 divided by 4. And again, I'm already in degrees, so I don't have to worry about that. I hit enter, and it's going to give me the angle in degrees. So 75, let's just say 0.5. So angle A is equal to 75.5 degrees. And the degrees is the unit, so I don't have to write units or anything. The degrees is the unit. And there it is. That's it. If I want to find the measure of angle B, I'm going to do the same thing. Well, there's two ways. One, you could just do 180 minus 90, right, minus 75.5. Or because I want to show you the trig function again, or the inverse, I mean, we're just going to do this process again. So for B, I need to look. 1 is opposite now of B. And then the 4 is still the hypotenuse. So now I'm going to be using sine because sine is opposite over hypotenuse. So sine of B is equal to 1/4, opposite over hypotenuse. And then I'll just do the same thing. Now I want to take the sine inverse of both sides, because that will help me figure out what B is. So I get B is equal to the sine inverse of 1/4. And I'm going to go to my calculator, and now I'm going to do second sine inverse of 1/4. And I get 14, and we can round this up 0.5. So, angle B is equal to 14.5 degrees. And if I add up these three angles, 75.5 plus 14.5 plus 90, I will get 180, which makes sense because that's what a triangle adds to. Okay. All right, so using our inverse functions, I do want you to try these two. What is the measure of angle P? What is the measure of angle Q? I will put that SOHCAHTOA back up if that is helpful. You should be writing it, whenever you need it. My dog is eating his tail right now, which is kind of funny. So go ahead and pause the video. Try it, find the measure of angle P, find the measure of angle Q, and then when you're ready to go over it, let me know and just hit play. Okay, so hopefully you tried it at this point. If not, make sure you pause it, try it, and then hit play. Let's start with the measure of angle P. So P right here, right? And I have to see what I have. I have 2, which is opposite of P, and I have 3, which is adjacent of P. So looking at SOHCAHTOA, tangent here uses opposite and adjacent. So in this problem, I'm going to be using tangent of my angle is equal to opposite, which is 2, over adjacent, which is 3. Okay. So to get rid of that tangent, I'm going to take the tangent inverse of both sides, which leaves me with P equals the tangent inverse of 2/3. And so when I go to enter this into my calculator, I'm going to do second now tangent inverse of 2 divided by 3. I'm still in degrees. Always make sure you're in degrees. And I get 33.69. So P is about, I kind of like to round to only one decimal place. So let's do 33.7 degrees. So angle P is about 33.7 degrees. Okay, so now for part B, if I want to do angle Q, now I'm looking here, right? And now I need to see what I have. Well, I have 3, which is opposite, because it's a cross, and then I have 2, which is adjacent because it's touching it, right? So what trig ratio uses opposite and adjacent, and it's tangent again. So I'm going to have tangent of angle Q is equal to opposite. Now my opposite is 3, so 3 on top, and my adjacent is 2. So again, we take the tangent inverse of both sides, and I get Q. Sorry, my dog just hit my leg. Q equals the tangent inverse 3/2. And so I'm going to enter that into my calculator. So now I'm going to do tangent inverse of 3 divided by 2, which is 56.31. So we'll just leave it at 0.3. So angle Q, let's find my angle, is about, what did I say? I don't even remember. 56.3 degrees. So using these trig ratios helps me find missing pieces of my triangle that I might not have been able to find before. That's it for 8.2. I know that was a long one, but this is kind of like the base and like the the foundation for everything else that we're doing in Unit 8, so it's really important that we are understanding our trig ratios. With that being said, if you have any questions or if you need any help, make sure you reach out. I'm happy to go over any of these problems in person or whatever you need. So just make sure that you reach out and get help if you need. And we'll see you next video.